Hello Internet, my name is Quinn and this is Blondihacks. I'm going to make a tool today for shortening tiny screws. This is especially useful, I think, for model engineering, that's why I'm doing it, but I could see it also being helpful for clockmakers, watchmakers, anyone else who frequently needs to shorten tiny screws in an accurate and convenient and repeatable way. So let's go. A couple of years ago I needed to shorten a screw and I had this random scrap of aluminum sitting on my bench, so I tapped a hole in it, clamped it into my vise, threaded the screw into it, measured the length sticking out the back that I wanted to remove, and then used this chunk of aluminum as kind of a fence to make a nice clean cut on the end of the screw. And it worked great. So I kept this scrap of aluminum, and then I added another hole to it the next time I needed to shorten a different thread, and so on and so on. And well, now I have this weird, janky aluminum angle that is, as you can see, very wallowed out, and also very chewed up on the back from saw cuts because, shocker of the year, aluminum, especially 1/16th worth of it, is not very good at holding threads nor resisting cutting forces from a hardened saw. This was never designed as a tool, it just kind of evolved and has turned out to work really well and has become my favorite way of shortening tiny screws. If you're not familiar with model engineering or similar pursuits, this is something you need to do a lot of because tiny screws really only come in one or two long lengths and you're expected to shorten them for your application. And on something like this model locomotive that I'm building, it's held together with thousands of tiny screws, every single one of which is pretty much a custom length. I know you're going to fill up the comments with suggestions for various clippers and snips and such that you use for this, but I've not found any other method for me personally that works as quickly as this and as cleanly as this and as accurately as this. And unlike any kind of snippers, it does not deform the end of the screw. One of my patrons actually filled me in on lantern chucks, which are a traditional way model engineers have shortened screws on the lathe. However, they're fairly complex to build and pretty slow. It's more of like, I think, a perfectionist thing rather than an efficiency thing, because I think the method I'm showing here is quite a bit quicker and doesn't tie up the lathe. Quick sidebar, because someone will mention it, there's an old mechanics trick where you thread a nut onto a screw before cutting it off, and then when you unthread the nut, it, quote, fixes the threads. Yeah, that's actually kind of nonsense. What's actually happening is when you unthread the nut, it's just straightening out the burr that was left on the end of it. So yes, the screw does thread into something now, but there's still a burr on the end of it that's going to cause you trouble later. What you really want to do is chamfer the end lightly with a file, which removes the burr and also gives you back your starting thread that makes the bolt easy to get into a hole and easy to start. So my aluminum jig works great, it's just that it's worn out after a couple of years and I need to remake it. Since I'm going to remake it anyway, I'd like to fix the one thing that bugs me about it, which is that it requires two hands. You have to hold the screw on the other side of the fixture to keep it from turning while you saw. That's not a big deal if you're doing one, but if you're doing 50, your fingers actually get pretty sore squeezing those tiny little screw heads. So here is the tool that I came up to hopefully solve this problem. It's got all the screw sizes that I use from number 0 up to number 8. It doesn't go any larger than that because any larger than that you're not going to be shortening them with a fret saw because A, it would take forever, and B, larger screws tend to be steel and also are sometimes hardened. So you need to use a cutoff wheel on a Dremel or something similar to shorten them anyway. This is really just a tool for shortening tiny screws, mostly brass, but some small steel ones are okay as well. I'm going to make this out of 1018 steel, not because it's a great choice for machining, but because I have a lot of it, it's cheap like borscht, and I'm going to make it work. Start by lopping a chunk off of this rather long piece over on the bandsaw, and next I'm going to take the somewhat unusual step of cutting it in half lengthwise. This piece of stock is the closest one I had to the final dimensions that I wanted, but it is a little over twice as thick as I need. And certainly you could machine all of that material off, but that is quite a bit of material to remove. It's a lot of time on the milling machine and it's a lot of cutter wear. Machine tools are subtractive manufacturing, and the fastest subtractive tool is the bandsaw. This is a pretty long cut for a bandsaw, about 30 seconds, but this probably saved me an hour or an hour and a half on the milling machine. Not to mention, bandsaw blades are a lot cheaper than end mills. I'll go ahead and let that cool down a little bit, and then deburr it in preparation for milling setup. I've had people ask why I deburr saw cuts if I'm just going to mill them off anyway. We have to use deburred parts in the mill because the vise won't clamp properly on burrs, and if you try to do any kind of edge finding or other indicating, you can't if there's burrs because you're going to be edge finding on your burrs. Plus the parts are just a lot more pleasant to use if they're deburred. Deburring is never a waste of time. Deburr early and often. As you can see from the CAD model in the corner, there's kind of a belt line that runs around the middle of the part, and that's an important functional detail that also looks kind of neat, I thought. So I'm going to start by milling this piece down to the dimension of that little belt, because that's the largest dimension on the part on every axis. So I'm just kind of squaring it up, but squareness is not super critical here. I'm not doing a full proper squaring of stock. I've done a video on that in my Mill Skills playlist if you want to see how that's done, but that full procedure for maximum accuracy is very time consuming and frankly rarely actually necessary. Deburr early and often. After doing that first cut on one side, I was checking my dimensions to see where I'm at. I noticed the ends are accurate, but the center is actually about 10 thousandths thinner. And that's really interesting, and there's really only one possible explanation for that. The piece must be warped. And indeed it is. It is bananaed. I've talked about this in the past, but this is a common thing with cold rolled material like I started with, especially when you take long bandsaw cuts on it to end up with a thin piece. That really, in my experience, exaggerates this problem. What happens is the machining or cutting releases the internal stresses in the material that are put there by the steel mill, and the part warps. You can normalize the steel before cutting to prevent this problem, but for most parts it doesn't really become an issue. It's really only for these long, thin parts, and not all material warps quite this much, so it's usually not worth the effort to do the normalizing, so I tend to not to do it, but once in a while it bites me. I can show you the effect here by taking a really light cut on the other side of the piece. You can see how it only cut the ends. That was a 5 thousandths cut, and we know it's a 10 thousandths banana in the middle. So it just cut the ends, and that whole middle area there is untouched. Now if I take another 5 thou cut, now it cuts all the way across, except for one weird little low spot in the middle that's less than a thousandth thick, and that little low spot is just tolerance in the manufacturing of the material. So we've removed the banana, and we've just got a little bit of a tolerance low spot there, which we can remove with another light cut. And now that side is flat. So you can learn a lot about the behavior of steel and how it's made by taking light cuts and just seeing what it does. Note that the first side I cut still has a very slight banana to it, and that's because you can't actually remove banana by machining flat on both sides, because when you clamp the part down, it flattens the part out, you machine a flat surface, and then when you release the part, it springs back, and you just made a thinner banana. Now in my case, the warping wasn't enough to really matter, so I'm not going to bother doing the whole shimming procedure that's required to completely remove banana shape from a part. If you want to know more about that process, I covered it in my PM5 big steam engine build, because this is something that happens a lot when you're machining castings. Big castings especially, they often have some warp or twist in them from the foundry, and there's a procedure you need to use to properly remove that. But none of that's really important here. However, you can see that I'm now machining down the thin areas above and below the belt line on the first side of my part. And since someone's going to ask, that chip shield is from Priest Tools. You can pick one up from him if you'd like. It's pretty handy for these heavy milling cuts. They're throwing chips at you. While I'm in this setup, I'm going to take advantage of the edge finding and such that I've done to lay out and drill and tap all of the holes for the business end of this piece, where I'm actually going to be threading in the screws to be shortened. So I spot all of those real quick, and then I'm going to go through with my tap drill. This drill that you're seeing me use, by the way, is a Starrett 604 shrinking drill. You can't get them anymore, it's not in their current catalog, but you can find them at auction houses, that kind of thing. It's a really useful tool for this kind of job. Then a whole lot of tapping, which I will not make you watch because, well, you know what that looks like. If you're wondering why the clamping holes are threaded instead of just being smooth bores, it's because I don't want to crush the threads with the clamp, which would definitely happen with these tiny brass screws. Finally, I punch a large hole down below the belt to act as the flexure joint for the fixture. This is where everything is going to bend to create the clamping action. That all seems to have gone fine. Some deburring and cleanup to do, and then I can set up to make those relief cuts on the other side of the part to create the horizontal belt line here as well. The reason for thinning out the material is also because I want the screw area to be as thin as practical, because the thickness of the screw clamping area kind of sets the minimum length of screw that you can cut. I mean, sort of. You can also cut them on the same side of the fixture to create really short screws, but that's a lot more awkward, so I've tried to make this as thin as I think I can get away with. I knew this last cut was going to be really close to the top of the vise jaw, so here's a trick for managing that. I stop the cutter before doing my final downward translation so that if it does touch the vise, the cutter isn't spinning, so it's not going to hurt it. And then I put something thin under there to verify that it's not touching the vise. If it's thicker than the drawing, then it's not touching the vise, and clearance is clearance. Clearance. Obviously, I don't love cutting that close to the top of the vise, but if you're careful about it, you can do it. And in this case, it was either this or machine a custom height parallel to get it a couple of thousandths higher on the final cut. That setup was a bit awkward because I had the parallels under the lower half of the part only to get under that belt, but it worked just fine. That went pretty well. Now, some trickier cuts, unfortunately. I have to make similar relief cuts on the edges of the part. And I really wish I had done these first. Hindsight and all that, this order of operations was not great. But I thought I could do this kind of awkward setup using 4 parallels as packing to get around the belt. And this seemed like it was working, but I was getting vibration on this cut, which shouldn't happen if the vise is properly clamping on the part. And well, it wasn't. As you can see, that parallel drifting downwards and then touching the cutter. That was annoying, and now I get to stone the dings out of that parallel and set up this way instead. I decided to do this in 4 separate setups on the end of the vise, which worked fine, it just took longer. That belt feature added a lot of work to this project, but it was actually worthwhile, I think, as you'll see in the end when I show you how this is all intended to be used. Deburr early and often. Next is the trickiest operation. I need to make a slitting saw cut all the way down the center of this part. So I'm finding the top of the part with a feeler gauge under the saw so I don't scratch up the work. Then I translate the saw down by the thickness of that feeler, plus half the thickness of the saw, plus half the thickness of the work. And that should get the saw centered on that line of holes. And this is crucial because this slitting saw, which is the thinnest one I have, is just barely thinner than the smallest threaded hole, the 080 hole. And if this saw cut is too thick or it's not perfectly centered, it's going to blow away the threaded hole and defeat the entire purpose of the jig. For the larger holes, it's fine. Close enough is good enough. But for that small one, it kind of has to be as close to perfect as I can get it. So with bated breath, I went ahead and started this saw through that cut. You saw me check it with a magnifying glass beforehand with the work in behind the saw so I could kind of sanity check it. And by eye, it looked like it was off a little bit, but the holes have been hand chamfered, and hand chamfers are always a little bit uneven, so it can deceive you as to whether something's centered on a hole. So I decided to trust the measurements and not my eye in this case, and 99.9% of the time, that is the right move. Towards the end of the cut, I'm stabilizing with my hand to reduce vibration so it doesn't chatter, because I need to cut past the end of the vise jaw just through that belt line in order to be able to do this in 2 setups. The reason I have to do this in 2 setups is because I figured out why the 4 parallel clamping that I tried earlier didn't work. This top section of the piece that I'm cutting is actually 5 thousandths thicker than the lower section. That's why the parallels didn't clamp all the way across, because they were clamping on the thicker top part and the lower, thinner part was unclamped. That 5 thousandths is not random. That is the finishing cut that I was using when I was cutting the upper part of the piece. So clearly what happened is I forgot to do one of my finishing cuts, so the upper half ended up a little thicker. It's not going to hurt the function of the part at all, but it does mean I had to compensate by doing the slitting saw cut in 2 separate setups, similar to how I had to use 4 setups to cut the edges of the part because of that thickness difference. That's not a mistake I've ever made before, but I consider that a good thing. If you're making the same mistakes all the time, then you should worry. As long as you're always making new mistakes, then in theory you're getting better at this. At least that's what I tell myself as I'm crying myself to sleep every night. But no harm, no foul. Using 2 setups for that slitting saw cut actually worked out just fine. To deburr that long, thin cut, I found a triangular needle file, worked pretty well. Took some time and some patience to get in there and clean everything out. I ran a piece of paper down through that thin slot as well to try and get all the crud out of it. That slot has to be clean and deburred well, or it's not going to function well as a clamp. The end result is I got away with it. As you can see on the smallest hole, the slot is not perfectly centered. However, there are threads on both sides of the slot, and that is enough to make this work. So I guess I should have trusted my eye in that case. I must have done something a little bit wrong with my measurement, or maybe my feeler gauge technique wasn't very good. Not sure. For whatever reason, I didn't end up perfectly centered, but close enough. Let's give this a little test drive. As you can see, the purpose of the belt is that it holds the piece in the vise when the vise is loose. And then as I squeeze the vise, you can see the clamping action happening. And I tried to get that flexure joint as far below the business end as possible because that makes the clamping action as parallel as possible. Now in principle, with it unclamped, I should be able to thread a screw into the hole. I'll try the number 0 because that's the acid test. And yeah, that's not working great actually. The screw is difficult to thread in. I had to use a screwdriver. And you can see that the threading in has actually expanded the jaws a little bit. So there's something wrong here. What I found is there's quite a lot of lateral flex in these jaws, and that's a deal breaker because if the threads aren't perfectly aligned on either side of the slot, then the screw won't thread in nicely, and the threading action of the screw tends to push the two jaws apart laterally because of the differential force on either side of the thread. The thread itself is actually pushing them apart, so it's really self-defeating. I had to think about this for a while to see if I could solve this issue, and this is what I came up with. I got this little piece of scrap, and I'm going to square this up. And I'm going to mill a slot down the center of this. After doing an initial cut, I took careful side cuts of equal amounts on either side of that slot, just enlarging the slot a little bit at a time until I had a perfect fit on the end of the piece. This needs to be a very, very close slip fit or it won't function as intended. And that is looking really good. I can just push that in there, but it's actually kind of tricky to remove it. That's perfect. So that piece slides on there. It's like a little hat, a little keeper, if you will. And that, I think, should keep the jaws from being able to separate laterally like that. So let's give it a try. Oh, so much better. I can thread that in there perfectly by hand now. It's nice and loose. But then as I clamp down on it now with the vise, it gets tight, so the jaws are sliding in that little hat at the top, and it's keeping them aligned. And now I can cut this screw without having to hang on to it with the other hand, using the tool as a fence for a perfect cut. Everything working as hoped. That is fantastic. I kept the hat nice and thin so that I could sneak in under it with the fret saw for the top hole, the 080 hole, which is the real acid test. And again, that cut went perfectly. And then I cracked the vise loose, and I can unthread the shortened screw with just finger pressure. That is really working nicely. You can see how the tool sits on the jaws with the jaws loose because of the little belt. That is very, very nice. Very pleased with that. Well, since it seems to work, I busted out the Machinist's Pharmacy, and let's make it look a little bit nicer. I'm going to clean everything up, get it very thoroughly degreased with acetone. I'm going to be cold bluing it, and the quality of the result of cold bluing depends entirely on how well degreased the part is. That's the entire ball game. But before I do that, I'm going to attach the hat permanently with a little bit of Loctite 680. I'm putting this obviously only on one jaw so that the hat will stay in place, but the other jaw can move inside the little hat. I don't know how Loctite and cold bluing interact with each other, so just to be safe, I let that Loctite cure a good 20 minutes before I busted out the cold blue. I think they're probably compatible, but I've never tested that. Now, as I said, cleanliness is the secret to cold bluing, and this is not the best job I've done. The result is okay. You'll see some little splotches at the end where there's some bare spots, and that's where I didn't get it perfectly cleaned of oil, but, you know, this is just a tool, and it's going to work for a living, so it doesn't have to be perfect. After the bluing, then you need to oil it. It's really the oil that's doing most of the corrosion protection. The cold bluing by itself helps a little. It's a form of rust. That's what cold bluing is, but the oil is doing most of the job. Wipe off the excess oil. And there it is, looking a little bit sharper anyway. It's dressed for dinner. And to finalize this for functionality purposes, I'm going to stamp the size of each threaded hole next to it, because at a glance, it's not that easy to tell the difference between a number 2 and a number 3 hole, and I don't want to have to count the holes every time that I try to thread a screw into them. So some stamped numbers finish it up, and there it is. There's my little micro screw shortening tool. this seems to be working really well. Hopefully you'll see it on my channel lots, assuming it does actually work for me. And, well, maybe this is something you want to make too. As I said before, the drawings and CAD models for this are on my Patreon if you want to try building one. Thanks to my patrons for making all this happen, and I'll see you next time.